If you've ever had a star's interior, like that star's interior explained to you, you've probably heard of something called radiation pressure, which basically means light, and radiation is another word for light, pushing out against that star's insane gravity, keeping it from collapsing in on itself and becoming a neutron star. But you've probably wondered how light can carry momentum and can do that. Light can carry momentum, and it's given by this equation here, that h is Planck's constant, and this thing that looks like the half-life symbol is the wavelength of the light, and of course that's your momentum. It's insanely tiny because Planck's constant is tiny. And a qualitative explanation would be that light can actually carry mass, and this is effective mass, really. And that's given by the energy of that photon over c squared, which is, of course, the speed of light squared. And it's also insanely tiny, because the energy is usually insanely tiny, and the energy, right here, of course, Planck's constant times c over wavelength gives you the energy of the photon, and this effective mass thing is a mass-like property. If you were to enclose a bunch of photons inside a box that has perfectly transparent mirrors on the inside, and put that box on a perfectly precise scale, the scale would register ever so slightly more mass because of the photons being there, because mass isn't what you think it is. So yeah, that's why light can carry momentum, and even though the momentum carried by light is insanely tiny, the number of photons produced by the sun is so insanely huge that it can support the entire star from collapsing. So yeah, light can carry momentum.